And so here we have the 6E notes, part 2. Expressions with a fraction exponent can be written as radicals. That's the reason we're in the radical section here. If I have a raised to the 1 over n power, it can be written as the nth root of a. So notice that the denominator becomes the index of my radical. So let's do some examples with that. Example 3, I have 4 to the 1/2 power. So it's going to become a radical. The denominator of my fraction is going to be my index, and that 4 is going to go inside. So this is the square root of 4, which simplifies to 2. So 64 to the 1/3. Again, I'm going to write it as a radical. The denominator is 3, so that's going to be my index, and the 64 goes inside. And the cube root of 64 is 4. So 64 to the 1/3 power simplifies to 4. So C, now recall that if you have a negative in front of an exponential expression, it's the same as having a -1 times it. So this is like having -1 times, and then 9 to the 1/2 is going to be changed into the square root, so the 2 right there, of 9, which is 3. So this answer is actually -3. So here I have 1/4, 81 x to the 8th, the whole parentheses raised to the 1/4. So I'm going to again have a radical. It's going to have an index of 4 because my denominator is 4. And inside of this, I'll have an 81 x to the 8th. So the whole thing is going to go inside. Then I will take the 4th root of 81, which is 3, and the 4th root of x to the 8th, which is x squared. And finally, E, again, it's going to be a radical. It's going to have the denominator is 3, so I have a cube root, and the 5y goes inside. And I can't simplify either one of those. So we're good there. So if you look on the other side, you're going to see that there is some practice problems for you to try. So try those next, pause it, and then come back and we'll pick back up again. All right, so now that you've completed all these up here, let's go the next step and ask, what does 8 to the 2/3 mean? We know that 8 to the 1/3 means the cube root of 8, but what about 8 to the 2/3? So what we're going to do is we're going to take it and we're going to think of 8 to the 2/3, and we're going to kind of break this apart into 1/3 times 2. That's going to multiply to be 2/3. So that then would be 8 to the 1/3 then is the cube root of 8. And then there's their 2 that was on the outside of the parentheses. So the cube root of 8 is 2. So we have 2 squared. And this answer comes out to be 4. It works the same going the other direction. So say we said 8 to the 2/3 was actually 8 squared. So put your 2 on the inside and then parentheses raised to the 1/3. A power to a power multiplies to be that. So then if I did my parentheses 8 squared, I get 64 to the 1/3. That would mean the cube root of 64, and the cube root of 64 is 4. So you can see either way we go about it, we got the same answer. So x to the m over n is going to look like this. Again, the denominator is going to be the index, so it's going to be the nth root, and then x to the m power is going to go inside. We could also do the nth root of, and then the x, and then take this whole thing and raise it to the m power. So either way, we're going to get the same answer. You can see that's kind of the two things that we did when we did it there. So hint, most of the time, the second one, the nth root of a, figure it out first and then raise it to the m power will be easier to calculate than the nth root of a to the m. So example 4, 16 to the 3/2 power. So I'm going to have a square root. The index is going to be a 2 because that's the same as my, denominator there. 16 is going to go on the inside. And because I said it, we're going to raise this to the third power. So that's going to give me the square root of 16, which is 4. And then I've still got raised to the third power. And 4 to the third power, 4 times 4 times 4 is 64 for our answer. Notice if we'd put the 3 on the inside instead of on the outside, I would have had to do 16 to the third power first, which would have been a gigantic number that we then take the square root of, and the square root of that would have given us 64. It works out the same, but it's much harder to do 16 to the third than it is to do 4 to the third. All right, so B, again, we've got that little -1 out front, and then we've got the 25 to the 3/2 power. So then that's going to be a negative. And then here we got this, it's going to be, the index is going to be a 2 because it's the denominator's a 2. And we're going to have the 25. Then we're going to take the whole thing, and what the numerator is going to go on the outside like this. Now you're just going to have to keep repeating this over and over, and it will become second nature to you. So I have a negative. The square root of 25 is 5 cubed. And 5 to the third power is 125. This is going to become a negative 125. So notice we do this whole thing first, and then that negative goes on the bottom right there. C, I have a negative 64 inside my parentheses and a 2/3 power, so the denominator is a 3. So cube root of negative 64. Take the whole thing and put the numerator exponent there, 2. So then I have the cube root of negative 64, which is -4. And -4 is positive 16. So at this time, we got some more examples to do. So we'll keep going on this. So here I have negative 27x to the 6 to the 2/3 power. So that's going to be the cube root of negative 27 x to the 6. I'm going to take my answer and square it. So the cube root of negative 27, that's a -3. The cube root of x to the 6, x squared. And then I want to square that. And that's going to give me a positive 9. Power to power, I'm going to multiply and get x to the 4th. E, I've got the square root of 9a squared. Take the whole thing, and numerator is going to be to the 3rd power. That will be 3a to the 3rd power. So then 3 times 3 times 3 is 27, a to the 3rd. And finally, this last one, I'm going to have the 4th root of that whole parenthesis. So inside of here, I've got 4x minus 5. And I'm going to take that whole thing and raise it to the 3rd power. Now I want you to try these practices before you move on.